So every time you type an AI prompt or like stream a 4K video or run a massive cloud backup, you're quietly draining Earth out of real estate, power, and water. Welcome to the deep dive. Today we're looking at a stack of industry white papers from sources like Nova Space and Aerospace America, and they suggest a pretty radical solution. Basically, the only way to sustain our digital future might be to, well, shoot it into space.
Yeah, I mean, it sounds like pure science fiction, right? But the International Energy Agency projects that global data center electricity demand is going to literally double by 2030.
Double, wow.
Right, and we're just running out of terrestrial grid capacity. Not to mention the massive amounts of fresh water needed to cool these server farms. The physical infrastructure of the internet is basically hitting a wall.
Okay, let's unpack this. Because if Earth is tapped out, these white papers are proposing moving data centers off-planet, specifically into sun-synchronous orbit, or SSO. But, why that specific orbit?
Well, placing servers in SSO solves the energy bottleneck instantly. A satellite in a sun-synchronous orbit essentially rides the twilight line around the Earth.
The twilight line.
Exactly. Because of that specific trajectory, it stays in perpetual sunlight. So the solar panels are almost never in the Earth's shadow.
Oh, I get it. So you're moving the power generation and the compute to an environment where energy is constantly abundant. It's like moving a massive, power-hungry factory out of a congested city and placing it in an infinite desert where the sun never sets.
That's a perfect analogy. You completely sidestep Earth's nighttime and weather interruptions. Limitless space, limitless power.
Wait a minute, though. I'm picturing these massive orbital servers running incredibly hot, but space is notoriously freezing. So shouldn't keeping a server cold in orbit be, like, the easiest part of this whole equation?
You'd think so, but what's fascinating here is that it's a really common misconception that deep space is a natural refrigerator. I mean, while it is cold, space is also a near-perfect vacuum, which means there is no medium for convective heat transfer. On Earth, we use fans or liquid cooling to physically carry heat away from components.
Ah, I see. So because there's no air, standard cooling mechanisms are completely useless.
Exactly. In a vacuum, you can't just blow the heat away.
It's like trying to cool down a boiling hot cup of coffee inside a perfect thermos, right? Without a medium to pull the heat away, the heat from those processors has nowhere to go.
Yes, you essentially have a machine trapped in an insulating blanket. The only way for heat to escape in a vacuum is through thermal radiation. You have to release it directly into space as infrared radiation.
And I'm guessing that requires some specialized hardware.
Very specialized. To cool a massive orbital data center this way, you have to build immense radiator panels. We are talking about structures stretching into millions of square feet just to dissipate the waste heat.
Millions of square feet. But how do you justify the cost of launching something that massive? I mean, you can't, right? At least not with traditional aerospace math.
Definitely not. Nova Space estimates that a hypothetical 1 gigawatt orbital constellation would cost roughly $46 billion over 5 years. A terrestrial equivalent is only about $17 billion.
Okay, so right now, it is absolutely not cost competitive.
No, satellite manufacturing and the sheer payload weight make it prohibitive. But you can justify the economics if you fundamentally change the cost of getting to orbit.
Which is exactly what reusable rockets are doing. And this is where it directly impacts you, the listener. Because when you run a heavy AI task today, you're obviously not paying for a rocket launch.
No, thankfully.
But historically, launch costs exceeded $20,000 per kilogram. By the mid-2030s, industry estimates suggest reusable heavy-lift rockets could drop that to under $200 per kilogram.
It's a massive shift.
Right. So by 2035, your AI subscription might literally be funding orbital hardware.
And that dramatic drop in launch costs is shifting this from a theoretical thought experiment into an actual corporate space race. Tech giants and aerospace companies are actively building out the architecture as we speak.
Yeah, we're already seeing the blueprints. Companies are proposing massive constellations like Starmine, which could scale up to 1 million satellites, or exploring Project Suncatcher.
And startups like StarCloud aren't just theorizing. They are actively testing GPUs in orbit right now to see how off-the-shelf silicon handles radiation and vacuum conditions.
It's wild. But if we connect this to the bigger picture, the primary bottleneck for the next generation of artificial intelligence isn't going to be software or algorithms.
No, it's physical infrastructure.
So the physics are solvable and the economics are rapidly getting there, but the white papers highlight a completely different kind of bottleneck, which is the law.
Yes, because the technology is moving significantly faster than the regulatory frameworks designed to govern it.
Right. Which leaves us with a massive unresolved question to ponder. Let's say this all goes according to plan. If your personal data or your banking information or your company's proprietary AI queries are processed 500 kilometers above the planet, who governs data sovereignty?
It's a huge unknown.
Yeah. Exactly. Whose cybersecurity laws actually apply in an off-world environment? We might figure out how to pave the stars, but we still have to figure out who writes the rules up there.
Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.